Hello ACI members and followers. I am Sundar Chittiraputhiran. I am a materials consulting associate at CTL Group. Before I start, I would like to thank the American Concrete Institute for this wonderful opportunity and my company CTL Group for encouraging me to do this. The topic for today's webinar is going to be testing coal combustion products CCP for potential harvesting. In today's world, there is a lot of focus on sustainability and circular economy. Concrete industry is also moving towards that. So reusing byproducts is very important. People often refer to these products as waste. However, there is nothing called waste. It is just that we have not figured out the beneficial reuse of these products. So for today's presentation, I'll be covering about the coal combustion products, harvested ash in particular, and then we'll be also discussing about some of the ASTM test procedures that are associated with these products. And then finally, I'll be covering about the Type 1L Portland-limestone cement. Coal-fired power plants are facilities that burn coal to make steam in order to generate electricity. So there are three main byproducts of coal combustion. One is fly ash, bottom ash, and also gypsum. For decades, these coal combustion products are used to make blended cements and sustainable concrete. Fly ash is a finely divided residue and that are transported from the combustion chamber by exhaust gases. They are removed by electrostatic precipitators in the process. Bottom ash, as the name suggests, they settle to the bottom of the combustion chamber and they are much coarser particles when compared to the fly ash. Gypsum, we are not going to cover much of that in today's presentation, but gypsum is typically used in the manufacturing of drywall because of its inherent fire resistance properties. It is also used in the manufacturing of cement, and interestingly, it is also used as a fertilizer in agriculture. So these are some of the terminologies associated with coal combustion products. Fly ash and bottom ash I covered in the previous slide. These fly ash and bottom ash, they are present in landfills. They have been like stored in landfills and ponds for quite some time, over decades. Because of the reduction in the coal power generation and coal power plants are getting shut down, we need fly ash and bottom ash to be used in concrete. So this commingled ash comes into play. So we need to dry and ground it to fineness to meet the ASTM C618 specification in order for us to use this commingled ash. So in order for that, we need to do some processing, and this processed commingled ash is called the harvested ash. ASTM C618 is a standard specification for fly ash and natural pozzolan for use in concrete. There are two different sections, one for the chemical composition and another one is for the physical properties. Chemical composition covers the oxide analysis, the chemicals that are present in the fly ash, and loss on ignition is one important property which is related to the amount of carbon that is present in the fly ash. There are physical tests that needs to be performed, like fineness, strength activity index, and so forth. All these properties are very important. We need to test that and make sure that it meets this specification in order for us to use in concrete. In the previous slide, we saw the ASTM C618, and that's a specification. And all the test methods that are mentioned in the ASTM C618, and most of them are covered in the ASTM called ASTM C311. And there are some of these properties are highlighted, which will be important for fly ash, and also it will be important for the harvested ash, which we will be seeing in the coming slides. There are many changes that's been happening in the ASTM specifications and also the test methods. One of the main change that has happened recently is changing from coal fly ash to coal ash in ASTM C618 specification. This is a very significant change because it covers fly ash, bottom ash, and also the harvested ash under the umbrella of coal ash for it to be used in concrete. There are two different fly ashes. One is a high calcium fly ash and called the class C fly ash, and another one is a low calcium fly ash called the class F fly ash. This slide shows the chemical analysis that was performed on two different fly ashes. Both these fly ash that are shown in this slide are class F low calcium fly ashes. The oxide analysis was performed using X-ray fluorescence spectrometry, and the loss on ignition was performed using thermogravimetric analysis. This is a typical chemical analysis that what you see in a ASTM C618 specification. Harvested ash is gaining more popularity very recently. As the coal powered plants are getting shut down, but the fly ash, on the other hand, is very important for concrete. So, harvested ash, the ash that are present in landfills or has to be processed and then it has to be used in concrete. So this pictures, there are two pictures. The one on the left shows the fly ash that are present in landfills, and they are taking it out and then processing it on the manufacturing facilities on the right side, to remove the excess moisture and also to make it suitable for use in concrete. However, this harvested ash has a lot of challenges, like high moisture content, high LOI, presence of free lime or excess alkalis or sulfur, contamination of ash with salt, soil, and organic materials, and the heterogeneity in the fly ash properties within a landfill or pond. And also the reduction in the fly ash reactivity due to agglomeration and partial reaction as a result of long-term exposure to moisture. So these challenges need to be overcome in order for the harvested ash to be used in concrete. The chemistry of harvested ash is not going to change much, and it's not going to be very different from the fly ash that's traditionally used in concrete. However, there are a lot of challenges, as I mentioned previously. Some of the properties, like the moisture content, the fineness, and the loss on ignition, that we need to make sure that we meet the ASTM C618 specifications for those properties before we can use the harvested ash in concrete. There is an additional fineness specification that has been added recently in ASTM C618 in order to allow the use of harvested ash. And but at the same time, we need to really make sure the moisture content, the LOI, and all those other properties also we meet the ASTM C618 before we can use it in concrete. So the first property that we will look at it more deeply is the particle size analysis. Fly ash is used in concrete primarily for two important reasons. So one is the its pozzolanic behavior, and the other one is the long-term durability that it brings to the concrete. The rate of pozzolanic activity is affected by the fineness of the fly ash, and in turn it affects the workability of the concrete. So it is very important to have the right fineness that you want for fly ash. The SEM image that you see is a 2000x magnified image, and you can see a lot of spheres or spherical particles of fly ash, and this is what that helps with the workability of the concrete. It is fly ash is typically it is finer than the Portland cement and also lime, and its size ranges between 10 and 100 microns. It improves the fluidity, and it also improves the workability of the concrete. And in terms of the long-term durability performance, fly ash, what it does, it converts the weak calcium hydroxide, and converts them into the stronger calcium silicate hydrate over time, and that improves the long-term performance of the concrete by using fly ash. So we have like two milling machines, grinding machines. One is a 40-pound mill machine, another one is a 10-pound mill machines. These machines are used for grinding harvested ash and grinding it to like 1 or 2 microns in size. And it will be retained on number 35 325 sieve. Generally, this grinding process it increases the fineness of fly ash, and which in turn helps in improving the strength of the concrete that is made with this fly ash. The slide shows the fineness of harvested ash as received for 5 different fly ashes A, B, C, D, and E. The testing was performed at CTL group. Y-axis it shows the cumulative retained. The x-axis shows the increasing particle size, and D50 is your median particle size. So what is shown in this slide is there are different fly ashes, and the fineness for all these ashes are very different. And the one on the top is more finer, and the one on the bottom is coarser when compared to the one on the top. So what we can infer from this particular slide is that there is a lot of variability in as received ash that we get in lab. So at CTL group, we process these ashes, harvested ash that we receive, and we grind them using the milling machines that I showed before. This slide shows two different harvested ash, A and B, after and before processing. The y-axis shows the cumulative retained, and the x-axis shows the increasing particle size, and D50 is again the median particle size. What you can infer from this slide is the processed ash is more finer when compared to the as received ash, and the processed ash A is finer than the as received material, and the processed B is more finer than the processed A ash, as you can see. So we saw fineness and how fineness is very important for workability. The second property we are going to see is the strength activity index. Strength activity index is defined as the ratio of compressive strength of the motor mixed with pozzolan at 20% by weight of binder to the control motor. Strength activity index is a very important physical property. We will see how the fineness is correlated to the strength activity index in the next slide. This slide shows the influence of fineness on strength activity index. Previously, we saw like two different ashes, one ash A and another one is ash B. Both of them we showed the fineness before and after processing. As you remember, the ash B was more finer when compared to ash A after processing. In this slide, for the same fly ash, you see the processing of A did not really change the strength activity index much. But on the other hand, processing for B, it actually increased the strength activity index quite a bit. So that's what you are seeing here. So it also shows yeah, the importance of doing more testing and the variability that you see in different ashes when you compare the fineness with the strength activity index. So until now, we saw about harvested ash and the properties that are important for a harvested ash to be used in order for us to be used in concrete. From here, we will see about blended cement, because blended cements are very important to be discussed when we want the ash to be used with concrete. So the focus will be on type 1L Portland limestone cement from here on. So blended cements are nothing but it is produced by intergrinding or blending two or more fine materials. Portland cement or one or two forms of limestone, slag cement, and pozzolans like fly ash, silica fume, or clay. So it can be used as a sole cementitious material in concrete, or it can be used in combination with other SCMs. It should conform to the ASTM C595 specification, which is the standard specification for blended hydraulic cements. For ordinary Portland cement, the standard is C150. Um, so ASTM C595 it recognizes four classes of blended cements. Type 1L cement, also known as the Portland limestone cement, and we have Portland pozzolan cement, Portland blast furnace slag cement, and we also have ternary blended cements. So today the focus of today's topic is going to be on Portland limestone cement. This is growing really fast. In fact, Type 1L cement is going to almost replace entirely the Type 1-2 cement in the US. There are also like different other blended cements which has like low or moderate heat development and high or moderate sulfate resistance. All these are also covered in the C595 blended cement specification. Portland limestone cement is a blended cement made with higher limestone content. They are specified under ASTM C595 as type 1L. PLCs are made with Portland cement, nominally 10% and up to like 15% fine limestone. The performance of PLC is very similar, and the durability and the resilience is very similar when compared to the ordinary Portland cement. However, the advantage is it helps in reducing the carbon footprint up to 10%. It is a tested and a proven technology, and it's been widely used all over the world, especially in Europe and for decades, and also it has been used in Canada. Now it's gaining more popularity in US, and it's growing really fast. So when fly ash is used with different cements to measure the strength activity index, we see different values. So this is what we are showing in this slide, the effect of cement and fly ash on strength activity index. So the y-axis shows the strength activity index and the x-axis shows the compressive strength. So two different fly ash, class F and class G fly ash, when they are used with different cements, you see different strength activity index. So this is something that we need to keep in mind when testing strength activity index, and also when we are comparing and correlating fineness and other properties to strength activity index. PLC it has been common internationally for decades, but it is relatively very new to Northern America. There is a worldwide acceptance of PLC, and in US, most of the state Department of Transportation they have adopted provisions to use PLC. This is a recent um, thing that has been published in the Portland Cement Association website. And most of the state devotees are accepting Portland limestone cement in their projects. And you can see like most of the cement manufacturers in the US they have switched from the regular ordinary Portland cement to type 1L cement. So this slide shows different ASTM standards. ASTM C494, which is a standard specification for chemical admixtures for concrete. ASTM C1260, which is and 1567 and 1293, they are for alkali silica reaction. 1260 is a motor bar method, and 1567 is an accelerated motor bar method. C311, we mentioned about that previously. These are all standard test methods used for sampling and testing fly ash or natural pozzolan. for use in Portland cement concrete, and they are mentioned in the ASTM C618 specifications. The reason that I have mentioned all these ASTM standards is all these test methods say to use type 1 2 cement, and these needs update. We need to update this with type 1L cement. So all these standards will require changes, and ASTM is working on it, and we will be seeing those changes pretty soon. Summary, we saw about the ASTM C618 specification and harvested ash, and the challenges for harvested ash. So we have been getting like laboratory work in this area for the last 2 years, and it's continued to grow. And regarding the type 1L cement, the ordinary Portland cement is not going to be available, and most of the US cement manufacturers, they are already like they're converted from type 1 to cement to type 1L cement. And ASTM is also in the process of changing all their standards to incorporate the use of type 1L cement. So we have one big thing called the harvested ash, and that is also growing. And there is another thing that is growing parallelly is the type 1L cement. And both these two technologies has to meet at some point. So there is a need to develop a lot of data and a lot of testing that needs to happen in this arena. So the laboratory work for harvested use of harvested as a SCM with the blended cement, that the work has just begun, and there is more work that needs to happen in this area. As at CTL Group, we are experts in coal ash reuse methods, and we as a consulting and testing expertise in the sustainable materials arena, we consistently bring value to each project, providing innovative, practical, and cost-effective solutions for our clients. So if you need any help in this arena for coal ash, coal combustion, residual beneficial reuse, and waste management strategies, embodied carbon reduction strategies, and also research and development of new products using sustainable construction materials, please feel free to reach out to us. Thank you.